All right, today we're going to solve inequalities by addition and subtraction. We've been solving equations by addition and subtraction and multiplication. Now we're treating these, okay, now we're doing the exact same thing, but they have inequalities. There's a few things that are different, but for the most part, we do it just like there's an equal sign. What I tell my students is act like there's an equal sign at first. Right? There's a rule you'll need to know later, but right now all you need to know, okay, is you treat it just like there's an equal sign. What I do is I draw a line, okay, and I keep them equal on both sides. Meaning what I do to the left side, I do to the right. What I do to the right side, I do to the left. I'm trying to figure out, okay, x minus 12, whatever that is greater than or equal to 8. So I want to figure out what number for x, okay, the smallest number x could be that still makes this a true statement. So I add 12 to both sides to get x by itself. That's always the goal. I find out that x is greater than or equal to 20, meaning the smallest number x could be is 20, and this still be a true statement. Now what you have to do is check your work. You need to be able to check your work on this so you don't get it wrong, but also so you understand what you're doing. So plug 20 in there. What's 20 minus 12? 8. Is 8 greater than or equal to 8? Yes, so you must be right. So x could be anything greater than or equal to 20. All right? Before, when we'd have a problem like this, okay, the only thing x could be was what? 20, right? Now x could be anything either 20 or up. All right? So that's all inequalities do, is making it where it could be a bunch of numbers, a set of numbers. All right? 22 is greater than m minus 8. So I need to get m by itself. So I add 8 to both sides. Okay, 30 is greater than m, meaning 29 is the biggest number m could be, and this still be a true statement. Right?
What about 30?
No, because it doesn't say equal to. It said m is less than 30, or 30 is greater than m, right? Is 30 greater than 30? No. So m has to be 29 or 29.99. Okay? M is just anything less than 30. This is what we call set builder notation. You just need to write this. Okay? I don't use this throughout the year. But the book does, so I'm just letting you know. This is how they write something like this. Okay, the book says it's a concise way of writing a solution set. Okay, so this is just all this says. Okay, is that the set of all numbers x such that x is greater than or equal to 20. So for x could be any number that's greater than or equal to 20. That's all it says. That's the way they write it. Okay. I think that's unnecessary. You don't need to know. You don't need to be able to write like that. All right, but this is just so you know how they write in a book. So a lot of your answers, if they have multiple choice questions, this is what one of your answers might look like. And I'm showing you this so you don't panic because you don't know what that means. Now you do. Okay, this just means that x, for any number of x that's greater than or equal to 20, that's the answer. Yeah. Write this down. All right, so this is a multiple choice question that you'll see somewhat like that in your homework, and they're using set builder notation as the answers. So what we have to do is all we do is just solve for m. So we subtract 19 to both sides. M is greater than what? 37. So we find the answer that looks like that. We ignore the first part of it. Could it be A? Could it be B? Could it be D? No, my answer is C. For all numbers m, okay, such that m is greater than 37. That's all it says. Okay, all you need to know is you need to look for this part. M is greater than 37. All right, write this down. All right, so they give us this where we have variables on both sides. Okay, that's nothing to worry about. We've seen equations with variables on both sides. We know what to do. They give us a line here because they might give us some questions that they want us to graph on a number line, so you can kind of see what it looks like. We solve for A. We got to get A on this same side, so I subtract 3A to both sides. My goal is always to move these smaller ones so I keep my variable positive. That won't always be possible, but in this case it is, so I move this smaller one. I get 6 is less than or equal to A, because 4 minus 3 is 1. Then they want us to graph it. So I put 6 on here, I put 7, I go 5. Okay? I don't need you to spend a lot of time on a graph, drawing a number line. And I need to draw where A is greater than or equal to 6, or 6 is less than or equal to A. So I put a open circle or a closed circle around 6. Closed because it includes it. And A is everything greater than 6 or equal to it. So I draw an arrow going to the right.
I think we did.
Okay? Now, I had people last year try and say, well, I like to use the arrow. The arrow is telling me what? To go left. Did we draw it to the left? No. Okay? I don't like you using the arrow to figure out which direction you're going, but I will tell you this because most people will try and do it anyway. The only way you can use the arrow to know which direction you're going is if you have the variable on the left. If the variable's on the left, does it tell you which direction to draw the arrow? Okay, drawing it to the right, so you go that way. So if you want to do it that way, that's fine. But make sure your variable is on the left. If it's on the right, you will draw this wrong. Right?
Do the opposite. Right.
So you have to move the variable to the left. If you move the variable left, then you have to switch your sign. Okay? But I don't prefer you do it. But I know most of you will. You want to find easier ways of remembering. So just remember your variable has to be on your left to use the arrow. Now, make sure you change the sign. If you flip this over here, you got to change the sign. Okay? You can't write A is less than 6 when you had 6 is less than A. Alright, write this down. So we got 5H is less than or equal to 12 plus 4H. I got to get the variable on the same side. Like I said, I prefer to move the smaller one. So I move 4H to both sides by subtracting. 5H minus 4H is H. H is less than or equal to 12. Now I need to draw that on a number line. H includes 12, so it's a closed circle. And H is less than. Now remember, the variable is on the left, so I can use the arrow. So we're going to the left. Write this down. Alright, now I left off. Okay, there should be an N right there. It has to be. You don't know how to do it if there wasn't yet. Okay, so make sure there's an N to the 10.
Wow.
Now, we have to subtract 9 to both sides. Okay, to move the variable to the right, we want to move a smaller one. We have -1 is less than N. So we graph that. Now, in this case, it's less than. So it's going to be an open circle. Okay, now my variable's on the right. And this is the way I prefer it. I don't like you trying to use the arrow. So if you flipped it, move in to the left, and then you can flip your arrow and use it. But I just like to think, what's a number greater than -1? 0. So which side is it going to be? It's going to the right. Okay, don't use the arrow. Don't rely on something like that. Just think about it. What's a number bigger than -1? 0. So it's got to be to go into the right. Now, like I said, I can flip it, change my sign. Okay, now the arrow tells me which way to go, but I don't need to rely on something like that. Okay, you write this down. This is the words they use to describe, because later they're going to make you translate sentences into inequalities, and this is words they use. For the less than symbol, they use less than, but they also use the word few, or the phrase fewer than. For greater than, they also use more than. For less than or equal to, they use at most and no more, along with less than or equal to. And for greater than or equal to, they also use at least and no less than. All right, here's your homework.
Thank goodness.
You don't have to do 61.